In our last lesson for this unit, we're changing gears a little bit, and we're going to look at a few probabilities, specifically some permutations, combinations, and something called counting principle. We're actually going to start with counting principle. And the biggest thing with counting principle is we're trying to figure out, given choices or events, what are different ways that we could choose different items. And we have to keep in mind, do we have independent versus dependent events? So an independent event is where you choose something and the other outcomes don't have anything else to do with it. So independent, the outcome of the first event does not affect the outcome of the second. A dependent event is when it does. And so what we'll see is when we're looking at our sample problems, this might be the sort of thing where, we have, possible multiple choices to choose on a test question. And what you choose on that test question is not going to affect the answer on any other questions on the test. That would be an example of independent events. Dependent might be some scenario where you have a group of people and you're trying to figure out, like we are in example 4, we're choosing people for different offices like president or vice president. And, the order that we pick those people in is important. And if you pick somebody for president, they can't also be secretary or treasurer or any of the other offices. Okay, so counting principle, which we'll also see in a few examples, just says that if we can have something happen in m different ways and something else that's kind of associated with it can happen in n different ways, then we can look at the total number of combinations is going to be m times n. So actually, let's start with one of those examples. So a restaurant offers 4 salads, 3 sides, and 3 entrees on their menus. So how many different combinations of choices, if you choose one of each item, how many different kind of meals can you pick? Well, when you pick a salad, again, you've got 4 options. And so we have 4 choices for that first option. Second option, picking a side, well, we have 3 of those. We're just going to multiply by 3. And then we have 5 entrees that we could choose. So rather than trying to map out all of the different combinations, which there's going to be a good number of them, I can just multiply all the different possibilities together. This is our counting principle in action. And so 4 times 3 times 5, we multiply those together and we get 60. So there are 60 different meals that we could create. So again, we're just multiplying the possibilities together for each choice. Okay, so let's do that again. Example 2, you want to purchase a movie, and there's 5 available, but each of those 5 movies, you could get it on VHS, DVD, or Blu-ray. So again, I know VHS, probably before some people's time, but I know there's still a few out there. I think our school has actually gotten rid of all of the VHS players. I don't think I even have one in the house anymore. And then most people probably have some form of DVD or Blu-ray. Most computers have a DVD drive or a Blu-ray drive. So a lot of people use their computers to watch movies now. Okay, so how many choices do you have of, what you could purchase? So again, 5 different movies, and you've got 3 choices for each type of movie. So you have movie 1 in 3 formats, movie 2 in 3 formats. So we're going to say we have 5 movies times the 3 formats. So we technically have 15 different choices. Again, 5 movies, 3 formats. Okay, let's look at the independent, dependent examples. So there are 3 multiple choice questions on a test. And they all have A, B, C, or D. How many different ways can you answer these 3 questions? And so again, does the answer for one question dictate what the answer for another question is? Not necessarily, because they could be arranged any possible way. So that means on the first question, you have 4 choices. And on the next one, you have 4 choices. And on the next one, you have 4 choices. It's not going to change on each question. So these are technically independent events from each other. Okay. And so our first choice does not detract from our second choice, does not detract from our third choice. So we're just doing 4 times 4 times 4, which comes out to 64 ways you could answer those 3 questions. But our next one is a dependent. So 10 people are running for president, vice president, secretary, and treasurer. So 4 offices that need to be filled. So if somebody gets elected for president, they can't also be vice president, secretary, treasurer. Again, there may be some situations in real life where that might be the case, but honestly, you're going to have enough work holding one office rather than doing multiple things, multiple office responsibilities. So these are dependent events. So dependent events. Because as soon as you make a choice for president, and you could choose any one of those 10 people, so 10 choices for that first office, well, now there's only 9 people to choose from for the next office, vice president. And now that we've chosen vice president, there's only 8 people to choose for secretary. And after you've chosen secretary, only 7 people to choose for treasurer. We're kind of removing that choice that we made for each of the previous offices. So we're going to do 10 times 9 times 8 times 7, which comes out to 5,040 options or different combinations of who could be chosen. So imagine all the different ways you could do if you have like a class at, Atlee or any of the other schools, you potentially have, almost 400 people in your class. Think of the number of combinations you could have if everybody ran for an office. Lots of combinations. But let's think about that math a little bit. We did 10 times 9 times 8 times 7. So what we're doing is we're kind of multiplying by all of the integers that come down from our starting choice. And so that actually has a name. When we start multiplying everything all the way down, if we went all the way down to 1, that would actually be called factorial. So factorial is the product of an integer and all the integers below it. So for example, 5 factorial is really going to mean 5 times 4 times 3 times 2 times 1, which all multiplies out to 120. Now, are you going to want to do this with large numbers? Absolutely not. So there's 2 ways that you could do this. If you're on Desmos, you could literally just type an exclamation point and it will calculate it for you because it understands what you're asking it to do. Now, if you're using a TI calculator, you've got to do this a little differently. So what you're going to have to do is actually go to your math menu and then open up the probability area. So PRB, it's the 4th one on the end. And then you're going to use option 4. That will type in an exclamation point after anything that you already have on your screen. So you want to type that in, you would say 5 and then go through the math menu to get the exclamation point. Again, a little easier to do on the Desmos calculator, which again, we'll have available for you on any of the questions that's appropriate for on the test. And you'll find that that's popping up in your lesson checks as well. Okay, and so we actually have a slightly more official way of calculating this if we're not going to have to go all the way down to 1. And so this is what we do when we have a permutation. So a permutation is we have a group of a possible number of choices, and we only want to choose so many of them. So kind of like the election problem example 4, we had 10 people to choose from, but we had 4 possible choices that we had to make for the 4 offices. And so permutation, we're going to take a group of R choices from a group of N total options, and we call this NPR, just like the radio station. So NPR or N permutation over R means total possibilities N, numbers that we're going to choose R. So if I actually go through and do this with example 4, I would get exactly the same numbers. When you're calculating NPR, again, you have a formula actually on your formula sheet. So the formula looks like this. So you could plug those values in and you will have that for reference, but honestly, it is so much easier just to do it on the calculator. And so the 2 options are on Desmos, which I'm going to show you in this video. It's actually one of the functions under your stat menu. And so you pull that up and then you just have to tell the calculator what your N and your R values are. If you're doing this on a TI calculator, you need to pull up the math menu and go into the probability menu again. And you'll see NPR as a choice, should be option 2 under that menu. Now the kicker with this is you do need to type that N value first. So for example, if you were going to do 5P3, you would have to type the 5 in first, and then type in all of your info to do the NPR, and then type in the 3 that you're going to use. And it will look exactly like that on your screen once you have stuff typed in. Alrighty, let's do a few problems. So example 6, how many ways can first, second, and third place be chosen from 20 competitors? And just like with the election, the order that we pick people in matters because first place is different than third place. So order is mattering on this one. Order is important. So officially, our formula would be, we have 20 people to choose from, and we have 3 choices to make for first, second, and third place. So we could just type in our calculator 20p3. And actually, let me switch over to Desmos to show you how it looks. Okay, so again, we need to be on whatever space we're typing this into. I'm going to open up my keyboard, go to my functions, and we're going to go under. Actually, that was under stats. And so you'll look down towards the bottom, we have this NPR right above T-score. Again, there's another one, NCR, which we're going to do in a few minutes. So hit that button, and it has a set of parentheses, and you'll notice it actually popped up with a triangle as well because it's waiting for those values. And just type them in the order that they show up in the formula. So our N value, we want 20, comma, our R value, we want 3. So we're trying to make 3 possible choices out of 20 available options. And so we end up getting 6,840. Now we could have done this kind of brute force. We could have just done, well, our first choice, first place, we have 20 people to choose from. Second place, we would now have 19 to choose from, and 18 left for third place. And that comes out to the same value. It still comes out to the 6,840. Alrighty. Example 7, how many different ways can you choose an actor and his understudy from a group of 14? So again, does the order matter? Well, yeah, the main actor is kind of the first place person, and then second place person is understudy. They're still responsible for learning the lines, but they're probably not going to be front and center unless something unfortunate happens to the main actor. So again, we have a group of 14 to choose from. So 14p, and we're just choosing groups of 2 people. So again, you could plug it into your calculator straight out. So 14p2, or this is another one of those situations we could say, well, we have 14 choices for the first actor, and then we have 13 choices for the understudy. Multiply that out in either method, you should be getting 182 different ways. So again, if order is important, you want to use a permutation. NPR, first number is always how many you have to choose from, and the second number is always what kind of groups are you trying to make. Now the last one that we're going to do is combination. And so you've heard of this with like a combination lock, and that's actually a misnomer. Because if you have a combination lock where one of those where you kind of twist around and have to hit the 3 numbers, the order you hit those 3 numbers is really important. So technically those should be called a permutation lock. Combinations, the order doesn't matter. So think about pizza toppings. If you choose 3 pizza toppings, doesn't matter what order really that you put them on the pizza, it's not so much. It's still all going to go in the oven and cook up. Okay, so a combination, same kind of setup. Taking a group of however many choices from a total number of options. So it's still the same R and N values. And again, usually you're going to use the NCR, but again, that formula, the N factorial divided by R factorial times N minus R factorial, that is available on your formula sheet. So if for some reason everything goes wonky on your SOL, you still have that formula for reference that you could use if you need to. But it's a whole lot easier just to plug it in the calculator. And so same thing in Desmos, you can just hit the button and then type in the numbers you need to use. Or if you're doing this on the TI calculator, again, you'd have to type that first number. So like 5C3, you'd have to type it in as 5, then find the NCR, and then type in the 3. Both ways will spit out the same answer. So let's look at a couple problems. Here we go. How many ways can you choose a committee of 5 people from 12 people? So again, the order doesn't matter for a committee. So if you just have 5 people working together on whatever task, yeah, you might choose people on, what jobs they may have in there. But again, the committee itself doesn't matter how you list those people out. It's the same 5 people. So this is going to be 12C5. And again, we don't have a super quick way to do the math on this. So let's just go ahead and type it in the calculator. So again, jumping over to Desmos, we're going to go ahead and type in, again, go to functions, and under stats, now we're going to use the NCR version. So just type in your 2 numbers in order that you see them, in the order that we wrote them in. Again, that second number is the size of the group that you're trying to choose, but the 12 is what you're choosing from. And so according to this, we've got 792 different ways that we could choose a committee of 5 people from just 12. So 792. Again, if order mattered, then we would have had a totally different scenario. We would have actually had more options. So just for reference, let's see what happens when we type that into the NPR. So again, I'm just going to update my numbers. Whoops. And apparently I deleted too much. So let me retype that. So NPR, and we're going 12, 5. Many more combinations when order matters. If order doesn't matter, like the combination, fewer, smaller answers are going to come out. Alrighty, example 7, which apparently I didn't renumber things very well. That should be example 9. I will update that on my printed copy. So how many ways can you choose 2 ice cream flavors from 15? So does the order matter on this? Well, they're going to go in the same bowl or the same cone. So 15, choose 2. And so again, just typing it in the calculator exactly the way it looks should spit out 105 choices. Alrighty, so that's the focus of these. So a few examples on each. I'm going to go ahead and record a second video that's going to go through all the extra examples that I have in these notes. So if you need some extra instruction on that, please do either try out those extra examples or watch the video and see me go through those. You have even more examples posted on Schoology and graded quizzes that you'll be checking out for this lesson. Ask me anything that you need to about any part of this lesson. Otherwise, have a great Friday.